Hello everyone, today we are going to study number system. Okay, this is your first chapter. So I'll start with number line. Okay, so what is a number line? Number line is something which is used to represent all the numbers. Okay, all the real numbers we represent on number line. We take it as 0, then this side we represent all the positive numbers, and on the left hand side we represent all the negative numbers. So this is our number line. Okay, so what are various types of numbers which we represent here? First one is natural number. So what are natural numbers? These are called counting numbers. Okay, the numbers which you use in counting. If you have to count how many students are there in the class, how will you start? You will start with, these are called counting number. So how will you start counting number of students in your class? You will start with 1, right? You won't start with 0. You will start with 1, 2, 3, 4. So like this you will go on. So natural numbers or counting numbers start with 1. Okay. Second one is whole number. Whole numbers is something which determine quantity. Okay, how much of something you have, that represents whole number. So if I ask you how many students are there in the class which have 0 students, are there when there are no students present, or how many pens do you have, how many pencils do you have? So if you don't have any pencils, you will answer 0. If you have 1 pencil, then you will answer 1 pencil. So this whole number starts with 0. So only difference between natural number and whole number is that whole number also include 0. Okay, like this. The next thing is fraction. Okay, so you represent 0, 1, 2, 3. This bracket becomes your natural number. When you include 0, then this becomes your whole number. Similarly, there's something called as fraction. So what is fraction? How much, if someone divides, for example, 1 chocolate among 2 students. So what there are 2 students, A and B, and both of them get half and half of this chocolate. Then what fraction of this whole chocolate does A have? Half. What fraction of B, this chocolate, does B have? Half. So fraction is part of whole. Okay, fraction is part of whole. What fraction of something you have? So this comes between here to here, or this mid region is corresponds to fraction. All the numbers between 0 to 1, 1 to 2, 2 to 3. So all of them are fractions. Next thing is integer. So what is an integer? Integer includes 0, 1, 2, 3, 4, something like that. So next thing is integer. Integer also includes negative numbers also. So yeah, -3, -2, -1, 0, 1, 2, like this on both sides. Okay. So next thing is a rational and irrational number. Next thing is a rational number. So what is a rational number? How it is defined, do you know? A rational number is anything which can be represented in the form of P by Q, okay? Which can be represented in the form of P by Q, where Q is not 0. Q is not equal to 0. Q cannot be 0. Q cannot be 0. And P and Q are integers. Okay, P and Q are integers. So a rational number is any number which can be represented in P by Q form, where Q is not 0 and P and Q are integers. So what are irrational number? Irrational number is anything which cannot be represented in P by, just opposite of rational number. Anything which cannot be represented in the form of P by Q, where P and Q are both integers and Q not equal to 0. So it cannot be represented in this form, P and Q integers. This cannot become something like this P by Q form. Okay, that is a irrational number. Okay, so a rational number, you know how to represent on our number line, right? 0, 1. So how to represent irrational number on a number line? Okay, this is our number line. So rational number, we can find that it will be some in between. For example, 2 is a rational number. 2 can be represented as 2 by 1, where this is not 0 and both the P by Q, P and Q both are integers, right? P is 2, Q is 1. So 2 is a rational number, 1 is a rational number, 3 is a rational number. So we can represent rational number on a number line. So how to represent irrational number on a number line? Example of irrational number is root 2, for example. So how to represent root 2 on number line? Okay, so next thing is how to represent root 2 on a number line. So we have our number line. This is, for example, our 0. Okay, this is R1. Okay, So what we'll do, we'll draw up a perpendicular to it of length 1 centimeter and join this Q. So this length is 1, this perpendicular length is, this length is 1. If you know Pythagoras theorem, that in a right angle triangle, Pythagoras theorem says that a square plus b square equal to c square. So from this a is 1, b is 1, so what is c? C square is 2, c is root 2. So this is root 2. This is our number line, right? This is 1 only we have represented. Similarly something like 2 will be there. So what we'll do is we'll draw an arc or draw a circle with center O and radius OQ, that is this. We'll create an arc on this number line. This is the point where root 2 will be there. Why? Because on a circle all the points are at equal distance from the center, that is OQ is equal to OM, right? Because both are radius of this circle which we draw. What is a circle? What is a circle? A circle is a curve on which all the points are equidistant from a particular point, which is called center. It is a curve on which all the points are equidistant from the center. That distance is called r. So if you take any point on the circle, it will be at a distance r. So this is the property of the circle that we are using, that we draw an arc and root 2 comes on this number line. Okay, this is our number line. Similarly we can represent root 3. How? This is root 2, right? We draw a perpendicular of length 1 centimeter and join this. How much will be this? By Pythagoras theorem, root 2 square plus 1 square, how much? 2 plus 1, that is 3, and root of 3. So this length is root 3. Similarly draw an arc with center O and radius this point, that is root 3. If you draw an arc, it will come here somewhere between 1 and 2, right? This is root 3. Okay. How to represent root 5 on number line? Root 5. It's easy, right? We take 0 at the starting point. There will be 1, there will be 2. 2. There will be 3. And more points. So we take 2, this length. What is root 5? We can break it as 4 plus 1, right? So 2 square is 4. We take 1 here and we join this point. This is root 5. We draw a curve, we get root 5. This is how we can represent all the irrational numbers on number line. Okay. Next thing is decimal expansion of rational numbers. Decimal expansion of rational numbers. Okay, we'll take three examples. First one is 10 by 3, second one is 7 by 8, third one is 1 by 7. Okay, so if you'll divide all these things, right, if you find the decimal expansion of 10 by 3, so what you will find is 3.333, something like this, repeating forever. Okay, if you expand this 7 by 8, then you'll find 0.875. If you'll expand this, then you'll find 0.142857, then again 142. This thing will keep repeating. Okay, this, after this you'll write 142,857, 142,857. This will carry on, and here remainder will be 1, remainder will be 7, remainder will be 1 if you don't convert it into decimal form. So from this, what you can find is, here remainder at last will become 0. Okay, if you keep on dividing, in this case this remainder will reoccur after few divisions. Here also this will reoccur after few divisions, but in this case finally the remainder will become 0. So when you divide, there are two cases, right? When you get the decimal expansion of a rational number, so there are two cases with the remainders when you keep on dividing. Either they become 0, like this case at last, or the second case where remainder starts repeating itself after a few things. For example, 1 will come, you will add 0, 10, it will again become 10, then you will further divide, 3 3 are 9, then remainder will again come 1. This process will remain. So either you will get a non-zero remainder, okay, which will repeat itself, or a 0 remainder at last. Okay, so the decimal expansion of a rational number gives us two kinds of results. First one is one with 0 remainder, or it is also called terminating decimal expansion, or the second one where we'll get some remainder which will repeat itself, that is called non-terminating recurring decimal expansion. Non-terminating recurring. Why recurring? Because the remainder keeps repeating itself, right? This is our non-terminating recurring decimal expansion or terminating decimal expansion. There are two kinds of things, right, when you expand a rational number. What happens in the case of irrational number? What we get when we try to expand root 2, then what we get is 1.41421356. What happens is the series goes on and we get non-terminating and non-recurring. decimal expansion. So what was happening in the decimal thing? This term was coming after certain number of terms here. The terms were getting repeated, right? We were able to put some bar. For example, this after 3, 3, 3, 3, 3, it was starting to repeat itself. In the case of irrational number, it never terminates. Okay, these all are this is also non-terminating, this is also not terminating, but this is recurring. Means the rational numbers or the fractional part of these things starts repeating itself. In this case, in the irrational number case, it doesn't repeat itself. So what we learned is the decimal expansion of rational number are of two type. First one is terminating one, where remainder becomes 0. Second one is non-terminating recurring one. In that case, certain remainders, non-zero remainder starts repeating itself. In the case of irrational number, we get non-terminating, non-recurring decimal expansion. Okay. So we go on to next thing. Let us take one example. Okay, irrational number. Irrational number. We have to find irrational number between 1/7 and 2/7. We have to find irrational. We have to give an example of one irrational number between 1/7 and 2/7. One by 7 can be written as 0.142857. This can be written as 0.285714, and this will also repeat itself. So any number between this which doesn't terminate, right? So irrational number which we can give is 0. It should be between 1 and 2. We can choose, right, any number, and between 4 and 8 it should be. So we choose 5. Now you can choose anything, something that doesn't terminate. That is 500, one something like 5001, some pattern which will keep on following. 5401, something like that. It will keep following. It will never terminate, right? Okay. So we can represent all the real numbers on the number line, all the irrational numbers on the real line. So what are the various operations that we can perform on real numbers? Operations on real number. What are the various operations that we can perform on real numbers? First one is addition. We can perform addition. Two root 2 plus 3 root 3. We can perform addition. We can perform multiplication and division. Multiplication, division, Okay, so we'll discuss few results. When we add rational number by rational number, the result is always a rational number. If I add 5 by 2, then it becomes 7. It is also a rational number, it is also a rational number, this is also a rational number. Okay, I will represent rational number with R and irrational number by IR. Okay, so I can, if I add two rational numbers, then I'll get a rational number. If I multiply two rational numbers, then I'll get a rational number. If I divide two rational number, then I'll get a rational number, right? Now, if I add an irrational number to a rational number, if I add a rational number to a irrational number, the result will be irrational, right? If I add 5 by root 2, then this is a irrational number, right? 5 plus root 2. If I multiply a rational number to an irrational number, 5 into root 2, the result is irrational. Rational into irrational number is irrational. Rational to irrational number is irrational. If I divide a rational number by irrational number, then the result is irrational. 5 by root 2 is a irrational number, right? It can be written as 5 by 2 root 2. I can multiply root 2 denominator and numerator. So this is a irrational number. What will happen if I add a irrational number with a irrational number? If I add an irrational number to an irrational number plus irrational number, the result can be anything, right? It can be rational number or irrational number. If I add 5 root 2 plus root 3 plus root 2, then the result is 6 root 2, so which is an irrational number. Yeah, and I can add 2 plus root 3, which is an irrational number, and I can add 2 minus root 3, which is an irrational number, but the result is a rational number, right? Similarly, I can multiply irrational number into irrational number or irrational number by irrational number. The result can be rational or irrational number. If I divide 5 root 2 by root 2, the result can be 5. But if I divide 5 root 3 by root 2, the result is 5 root 3 by 2. Similarly, if I multiply 5 root 2 into root 3, the result is 5 root 6. If I multiply 5 plus root 3 and 5 minus root 3, the result is 25 minus 3, there is 22, which is a rational. Or I can multiply root 2 into root 2, which is nothing but 2. So multiplication of two irrational number can result into a rational or irrational number. Anything is possible. Okay, next thing what we have here is how to find root x. Okay, or rather, if we are given that root a, okay, is equal to b, where b is a positive number and b is a, we know, right, whatever the a may be, if a is for example 4, then it may be a natural number, that is 2, or it may be some irrational number, which is, then also it will be a real number, right? So in any case, this b will be a real number if a is a positive number. If a is a number greater than 0, then we know that b will be a positive number. So how to find this b? How to find this root a, or for example root x, anything? So what we'll do is we'll create a line length x. Okay, we'll then from here, from this point, we'll create a line length 1. Okay, from here we'll create a line of length 1 centimeter. Then if we draw a semicircle considering this as a diameter, or rather taking this O as a center, where this is x plus 1 by 2, this length is x, this is 1. If we take this as diameter, then the radius will be x plus 1 by 2. Then this length, right, this is the point of length x. Then this length will be root x. How? Why will this be root x? So if I join this, we know this is a perpendicular. So if we see this triangle O A B, if we see this triangle, if I see this OAB triangle, sorry, this is O, this is O, this is A, and this is B. So what is this length? We know this whole length is this mn is x plus 1, right? This mn is x plus 1. What is on then? If mn is diameter, then on is what? Radius, right? So radius is half of diameter. Radius of a circle is half of diameter. So what will be the OB? OB will be how much? On minus 1, right? On minus 1, x plus 1 by 2 minus 1, which I can also write as x minus 1 by 2. So OB will be how much? X minus 1 by 2. What will be this length? See, this is also radius, right? OA. So this will also be equal to x plus 1 by 2. So what will be this length? Using Pythagoras theorem, if I use Pythagoras theorem, then OA square will be AB square plus OB square, right? OA square will be equal to I can write OA square will as I can write OA square as AB square plus OB square. What is OA? This is radius, so this is x plus 1 whole square, whole x plus 1 by 2 whole square. AB square, this is we want to find, right? We have said this is root x, so we will find how it is root x. So how AB is root x. So what is OB? This we found out what from here, x minus 1 by 2. So from here AB square is what? X plus 1 square by 4 minus x minus 1 square, right? This is also by 4, we can take denominator common, so x plus 1 whole square minus x minus 1 whole square by 4, right? So what is AB? AB square is x square plus 1 plus 2x minus x square minus 1 plus 2x by 4. This will get cancelled by these two. So what we get? 4x by 4, which is nothing else but x. So AB comes out to be root x, right? So if we draw a length MB as x, we extend it by 1 and draw a circle taking this x plus 1 as diameter, then this length AB is root x. This is how we find root x. Okay. Okay. So next thing is you remember this formula, x plus y into x minus y is equal to x square minus y square. Same thing we can use for the irrational number also. If root a plus root b into root a minus root b, what will be this? A minus b, right? Similarly, if I multiply two numbers and take its root, that is root ab, it will be same as if I take the root of a and I take the root of b and then multiply. Both are the same things. If I divide a number and take its root, it's very similar to I take the numerator's root a and I take denominator's root and then divide. Same thing. And or vice versa, that instead of doing this, you divide it and take root. So next thing is this one type of question which you can get in your exam is rationalize this number 2 plus root 3. You have to rationalize this. So how you rationalize this? What we do is we multiply numerator and denominator by 2 minus root 3. It's conjugate number. This is also called its conjugate. So we can multiply this by 2 minus root 3 numerator and denominator and use that formula root a plus root b into root a minus root b, or a plus root b into a minus root b will be what? A square minus b, x square minus y square, right? So this will become 2 square minus 3, and what will be the numerator? 2 minus root 3. So what is the answer? 2 minus root 3 by 1. Next thing is laws of exponent. That is a to power m into b to power n. This is a to the power of m plus n. Sorry, a to power m into a to power n is equal to a to the power m plus n. A to the power m to the power n is same as a to the power n to the power m, or a to power mn. A to the power m into b to the power m is same as ab to the power of m. A to the power m by b to the power n is same as, sorry, a to the power m by a to the power n is same as a to the power m minus n, where m greater than n. Normally we take that if this number has to be positive. It's not necessary, we also have 1 by a square, but this is how we take. What is a to the power of 0? This is 1. The power of 0 of any number is 1. And if I write something 1 by a to the power of m, then I can, this will be what? A to the power of 0, right? 1 is. So 0 minus m, or what is this? A to the power of minus m. Correct. So that's it for number system. Meet you in the next class.